Hi everyone, welcome back to my YouTube channel, Tech Data Engineer. Okay, so in this video, we will see Catalyst Optimizer. Okay, so progressing with our pyspark series. So in last video, we have seen what is data skewness. Then we have seen what is memory management, how memory is get managed in pyspark. So in this video, we will see what is Catalyst Optimizer and how this will help our pyspark job. Okay. So, before going through the definitions and all, first we will see what problem does Catalyst solve. Okay. So then we will see the definition of Catalyst optimizer and all. Okay. So first we will see what problem does Catalyst solve. Okay. So let us take an example. So suppose we have one Python code like. Okay. So I'll start with some more definition. So we'll take one Python code like suppose I'm just filtering some data. Okay, so I'm doing like df dot filter. Okay, then df I'm filtering df dot age that should be greater than 30 dot select, and then I'm selecting the name. Okay, name column. Okay, so I'm doing this. Okay, so I'm doing df dot filter, df dot age greater than 30. So I'm selecting the name of the persons whose age is greater than 30. Okay, so the first question is, does Spark immediately start reading data and filtering? Okay, so the answer is no. Like, does Spark immediately start reading data and filtering? Okay, so whenever we are writing this code, so does Spark immediately start reading this data, and start filtering or start optimizing? The answer is no. So Spark first thinks about the best way how to run your code. Okay, so this is your code, but whenever you are writing, so it is not suddenly getting executed. Okay, so this is the work of Catalyst Optimizer. So first Spark thinks the best way to run your code. Okay, so the thinking engine is called Catalyst Optimizer. Okay. So now we can see the definition. So Catalyst is a Spark brain. Okay. So this is one definition and this is the second definition. Either that both are fine. So Catalyst is a Spark's brain that decides how your code should run effectively. Okay. So this is the definition of this one. Another definition is a Catalyst is a Spark SQL brain. It takes your PySpark code. So I have written this code. So it takes this PySpark code, okay, PySpark data frame code, convert it into a logical plan, optimize it automatically, and generate the best possible execution plan. Okay, so it takes the code, it do like this, and then it run. Okay, so directly it is not like it is taking immediately and then they start reading the data and start filtering. Let's start reading the data like df dot is greater than 30, then filtering the data and giving the result. Okay, so first it will plan logical, first it do the logical plan, then it's optimize that plan, and then it execute that. Okay, finalize the execution plan. Okay, so the definition is Catalyst is a Spark's brain that decide how your code should run effectively. Okay, moving forward. So then the next question is what Catalyst actually does. Okay, so Catalyst, what actually it does. Okay, so suppose this is your code. Okay, I'm writing like suppose this is your code. Okay, let me increase the size. So what Catalyst does, I'll explain with some pictorial things. So suppose this is your code, right? Okay, so this is your code. Okay, this is your code. Your code. This is your code. Then it will generate the logical plan. Okay, it generate the logical plan. After logical plan, what it does? It optimize the logical plan. It optimize the basically it opti optimize the logical plan. Whatever the logical plan that it will optimize. Then what it does? It create the physical plan. Okay. It create the PHYSI. It create the physical plan. Then what it does? Then it after creating the physical plan, what it does? It does the execution. Okay. The next step is the execution. Okay. Next step is the execution. Okay, so first, whenever you are writing your code goes to the logical plan, then optimize logical plan, then physical plan, then execution. Okay, so these are the step. Let's go one by one with the our this one execution. Okay, so first I'll go through the logical plan. Okay, so let us go through the first plan that is called logical plan. Okay, logical plan. Okay, so let us understand with some code. Okay, so I'm writing like suppose I'm writing df dot filter. Okay, then I'm writing df dot country. Df dot country equals to US. Okay, and dot select ID comma name. Okay, so a Spark, so this is the logical phase, okay, logical plan. So Spark first create a logical plan, like it first read the table, okay. Sorry. So what it does, first it read the table, okay. First it read table. Then what it does, it filters row where country equals to filter rows where country equals to US. Okay, after what it does, it select ID and then name and name. Okay. So the important thing is no data read it. Okay. So it is just so this is not reading the data. Okay. This is just the plan it is creating. Okay. It is not reading the actual data. Okay. So that is no data read yet, no data read yet, no execution. Just understanding your intention. Just it is understanding your intention, like what you're writing as a code. Okay, it is just understanding. It is just understanding your intention. Okay, it is just understanding your intention through code. Okay, like what you want to do. Okay. So for in first plan, whenever you are writing the code like df.filter, df.country equal to US, that select ID name. It is selecting the ID name where country equals to US. So what it is doing, it is reading the table, filter row where country equals to US, and selecting ID and name. Okay. So that is no data read it, no execution, just understanding your intention through data. Okay. Coming to second part. The second part is like second part is optimized logical plan. Okay, optimized logical plan. Okay, optimize logical. That is a smart thinking. So, so now here in this phase, so so in this phase, basically optimize logical plan. So here, this catalyzer thinks, can I do this in some smart way? Okay. So yes, it can do. Okay. So how it can do? First option is, so it will do some optimization. So how it will do some optimization? So okay. So optimization steps like it will do something like column pruning. Second thing it can do like predicate push down. Okay. Predicate push down. What other things it can do? It can reorder the operation. Okay. Reordering operation. Okay. It can do this way. There are multiple way, but this can do like it can do the column pruning, then predicate push down and reordering the operation. Okay. So what it can do in case of pruning? Okay. So column pruning is you only need the whatever the ID unit. So in my case, what is needed? It is needed only the ID, comma, name and country. Only we require these three column. So it takes in case of column pruning. Okay. So Spark will not read the other column. Only it will read the this column which is required. So this comes under the column pruning. Okay. This comes under column pruning. Okay. Okay. Then the second is predicate push down. In case of predicate push down, if we are writing like df dot filter country equals to US. Okay. So if I am writing like this, instead of reading all the rows, okay, instead of reading all the rows, so instead of reading all rows and then filtering, Spark pushes filter down to the data source. Okay, so only so normal what you can do, it can reading or read all the data and then filter the country equals to OS. But no, it what how it will do only US rows are used. Okay, and so because of that, what will happen? That is a huge performance gain. Okay, because of predicate push down. Okay. So a Spark pushes filter down to data source like Parquet and then it will do the filtration. Okay. So because of that, what will do? It will because of that we are getting the huge performance gain. Okay. And then third is the reordering operations. Okay. We will understand this reordering also. Okay. So third operation is reordering. Okay. Reordering operation. Reordering operations. So if I'm writing like, so if you wrote like df dot select, then yeah, what I'm selecting ID, comma name. Okay, ID comma name dot filter country equals to US. Okay, okay. So what it do? Catalyst rewrite it internally. Okay, so catalyst what it do? Catalyst rewrite internally. Okay, so how it will do rewrite? First it will write like df dot filter part, df dot filter like country equals to US, and then it will select the data. Okay, like ID, and then it will selecting the name. Okay, Okay. So you don't need to write the perfect code. Catalyst will help in that case. Okay. So how you are writing your code, you have to write, but Catalyst will do the rest of the thing. Okay. So this way, basically, it will help in optimizing the plan. And then third is the we have physical plan. Okay. Physical plan. Okay. Or execution strategy. We can say like execution strategy also. Okay. So how a Spark decide? So how exactly should I run this? Okay. So in this case, part a Spark have to catalyzer have to think. So how exactly should I run this? Okay. Like which which join to use, which join to use. We have to do shuffle or broadcast based on your requirement, right? Based on your requirement, broadcast. How many stages? How many stages? So this everything this is decided by this is everything is decided by in the physical plan. Okay. So like if you are doing like big so suppose I'm writing like this one. Okay. So if I'm writing like suppose df dot big df dot df underscore big, okay, dot join, okay, then I'm doing df underscore small and based on id. Okay, so if I'm writing like this, so what it will do, so df dot small is tiny, we know. Okay, so df dot small is tiny, so basically it is doing the broadcast, it is broadcasting to all executor. Okay, so this is basically the broadcast join. Okay, else if it is not there, else we are going with the merge join. Okay, we are going with the merge join. Okay, so mostly you don't have to choose, it is chosen by at the time of physical plan, and it is chosen by catalyst. Okay, so catalyst does all these things. Okay, you don't have to choose most of the time. Okay, and the finally is execution. Okay, so fourth step is execution. So whenever doing so execution. Okay, fourth is the execution. So if doing like df dot count, okay, like any action is getting performed, so what it will do is sparks, what a sparks does, a sparks create task, a spark create task, then send it to, then what after creating task, what it do, it will send it to executor, executor, then after that what it will do, it will process the data. Okay, so this is happening in case of execution plan. Okay, this is the first step in case of, so in execution plan, it is doing the processing of your data. Okay, so this all are done in case of our catalyst optimizer. So going through the first, so what is catalyst optimizer? Before that we understand why problem, what problem does catalyst solve. Then we saw the definition, then we saw that what catalyst actual do. So your code, then logical plan, optimized plan, physical plan, and execution. Okay, so we understand each of the plan in detailed way. Okay, so after understanding each of the plan, we saw the execution. Okay, now the question is, one question I'm solving also, like why data frames are uh, why data frames are faster than RDD. Okay, why data frames are faster than RDD? So in case of RDD, there is no catalyst. Okay, no catalyst, no optimization. So this is one of the important question, why data frames are faster than RDD. So we can see like why this is faster, because no code list, no optimization, just raw. execution. Okay, but we have already seen that in case of data frame, in case of data frame, we have full catalyst optimization, full catalyst optimization, full catalyst optimization. Then we have better plan. Okay, it is going to the better plan, and then other we have like less memory uses. Okay, less memory uses. Okay, so these are the benefit. Because of that, data frames are faster than RDD. Okay, so basically RDD execute what you write and data frame execute what is optimal. Okay, so in case of if you are using RDD, if we are in case in using RDD, so whatever you are writing that is get executed, and here whatever you are writing the optimal get executed, optimal solution get executed. Okay, so this is the difference between RDD and data frame. Okay, so we will see some other topic in the next video. Okay, thank you, thanks for watching.